Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. If you cannot hear me, please raise your hand. Okay, so it's 2 o'clock, so let me begin, inshallah. Sidra, can you hear me? Sidra, can you hear me?
Yes, I can.
Okay, okay, okay. So we were discussing the chapter of quantitative analysis, and this is also called a stoichiometry. Stoichiometry. Stoichiometry means the study of the ratio of substances and the ratio of the products. At what ratio the reactants react with themselves, and at what ratio the product is formed. Okay, so the study of that ratio is called a stoichiometry. So this chapter deals with that. So we have done the concept of mole, and we have also done how to calculate the empirical and the molecular formula with the help of experimental results. And today we are going to find, today we are going to study the relationship of the mass of the reactants and the number of moles of the reactants and the number of moles of the product which is eventually produced, which is eventually formed. Now, in order to study that, we have to first of all understand the law of conservation of mass. You know, as the name itself is self-explanatory, it conservation means to save, to preserve, and mass. So basically what this is trying to imply is that the mass stays constant through the reaction. Through the reaction, the mass stays constant, meaning that the atoms rearrange themselves, but the total end product will be, the mass of the total end product will be equal to the total mass of the reactants that reacted. Because of course, mass cannot vanish into thin air, right? The mass is still there, the atoms are still there. But yes, practically speaking, some mass is lost to the environment, some mass is lost to the surroundings, and that we will deal with later on. But right now we are speaking of ideal conditions, okay? Neglecting the loss to the surroundings in ideal conditions, neglecting the loss to the surroundings. We know that the mass is not going to disappear anywhere. Mass is going to stay within the reaction, okay? So if we have one atom of iron, one atom of sulfur combining together to give a product which has both the atoms. So the product also has one mass of iron and one mass of sulfur. So if you add the masses, mass 1 mole, and I hope everybody knows what a mole is. Everybody understands what a mole is. What is a mole? Can anybody recap real quick for me? What is a mole? You don't have to give me the book definition. Whatever you understand, you should understand it correctly. What is your understanding of a mole? My old students, Ajwa, Yusra, come on. Okay, Nabil, good job. Yes, Nabil? Okay, yes?
The measure of amount of substance in chemistry. 1 mole of a substance has a mass equal to its relative formula mass in grams. That amount of substance contains 6.02 into 10 raised to the power 23, the Avogadro constant, atoms, molecules, or formula units, depending on the substance considered.
Very good, Nabil. Can I ask you that did you give this definition from your own, or did you read from somewhere? It's okay if you even if you read, but I want to know. And don't mute yourself back until I say okay. Oh, sorry. Yes, I'm sorry.
It is from the
Yeah. Sorry.
back of the book.
Oh,
It is
okay.
from the
Okay,
back of
that's
the
fine.
book.
Okay, that's
Sections
fine.
are
But do you
written. Yes,
understand it?
yes, you're right.
Okay. So
Yes,
yeah. Okay. So basically, in my last classes, and I will share my last classes. They are available on my YouTube channel, but I will again share in the group, in case you guys are facing difficulty in finding them out. So mole is, you know, an easy way that the scientists came up with in order to in order to count the number of atoms, because, you know, counting the actual number of atoms was practically not possible. Therefore, they came up with this easier method in which one mole, for example, this is 1 mole, okay? Just, you know, if this is 1 mole, this 1 mole will contain how many atoms? How many atoms will there be? Many atoms, okay? How many atoms? 6.02 into 10 to the power 23 particles. Why are we using the word particles? Because these particles can be atoms, molecules, ions, you know, depending upon what we are talking about. So 1 mole is just like, you know, you don't say that, okay, add 1,600,325 grains of salt in my curry. You don't say that, right? You don't say these humongous, tedious numbers. But what do you say? You say just add 1 spoon. Add 1 spoon of salt in my curry, right? 1 spoon will have approximately that many particles. So in the same way, 1 mole in chemistry is just like 1 spoon. Think of 1 mole as the spoon of chemistry. Okay, think of 1 mole as 1 spoon of chemistry that has 6.02 into 10 to the power 23 particles. Okay, 1 spoon or 1 mole has 6.02 into 10 to the power 23 particles. Okay, so knowing this, we know that 1 mole of iron has these many atoms of iron particle. And if you add their masses together, this is what you get. And I told you, when you are dealing with the mass of a mole, the unit is grams. The unit is gram. When you talk about mass of a mole is also called the molar mass, okay? And the unit is grams, okay, grams. So 1 mole of iron has a mass of 56 grams. And how did we know this? From the periodic table. Okay, these molar masses are given in the periodic table. This is my periodic table. So I can see that iron is 56. Can you see in the camera? Can you? I hope you can see it. So iron is 56, okay? And then sulfur is 32, okay? So I got these molar masses from this periodic table. In the periodic table, they did not write the units. They did not write grams. Why? Because this is a relative atomic mass. Relative means it's a ratio, and you don't write units for ratio, okay? But numerically, the molar mass is the same as the mass of one atom, but the units change. Here you don't have a unit, but in the case of mole, you have unit grams. So I hope everybody already knows that, but I did recap for the ones who might be new, who might be attending this class for the first time. Okay, so 1 mole of sulfur has a mass of 32 grams. And then if I add them up, I get 88 grams. Okay, so that's exactly the case it is. So that means the mass did not go anywhere. Okay, this is under ideal conditions, when we neglect the loss to the surroundings. But practically speaking, this is not common. Okay, so the law of conservation of mass states that the sum of the mass of reactants is equal to the mass of the product. Simple as that. Okay, that's common sense, law of conservation of mass. Okay, so in a chemical reaction, atoms only rearrange. Now here the atoms were separate. Here they are in a chemical bond. So that's the only difference. Okay, now they're bonded together. So they are bonded together. And so now they are behaving as one particle. Okay, initially there were two different particles. Before the reaction, there were two different particles. Okay, another thing is that the coefficients. What do I mean by coefficients? Coefficient spelling is this. Coefficient. Okay, coefficient are these numbers that you write on the left hand side of the symbol. Okay, not the small numbers that you write on the right hand side. No, the number that you write on the left hand side of the symbol, that is called a coefficient. So remember, a balanced chemical equation always gives us the ratio of the number of moles. I mean, a balanced chemical equation gives you a lot of other information as well, and this information is also one of those, that it tells us the ratio of the moles in which the reactants react and in which the product is formed. So what is this ratio telling us? Now, because there is no coefficient, that means there is one. We don't usually write one. We do not write one usually, but I wrote this one down to show you that there is one. So the ratio is 1:1:1, meaning 1 mole of iron is reacting with 1 mole of sulfur to give you 1 mole of iron sulfide. Okay. Okay. Okay, and also in my previous class, I emphasized on the fact that you will not use the mass ratio. Can you see this is the mass ratio, 56:32:88. Never use the mass ratio for your calculations. Always use the molar ratio. And why was that? I explained in my last class, and I will share the videos in the group, and you can go ahead and watch them, okay, if you are interested. So because you see, the mass ratio is not always equal to the molar ratio, and it is actually the number of moles that are reacting. So it is actually the number of moles that is important in stoichiometry. Okay, so we can use any mass of reactants, but they will always react in the same molar ratio as in a balanced chemical equation. So, I mean, you can use any unit here. If, for example, in industries, in factories, for example, in a factory which is producing iron sulfide, they will not be using grams, right? They will be using kilograms or tons, right? But the ratio of the moles will stay the same even in factories and industries. So no matter what unit you're using, even if you're using kilogram or you're using tons or whatever unit you're using, molar ratio will stay the same. And that is why molar ratio is more reliable, because it stays constant no matter what. This can change according to the units. This can change according to the circumstances, but this will never change no matter what, whether you know this reaction is going on in the industry or in a chemical lab, in a chemistry lab, or anywhere. The molar ratio is always gonna stay the same. Okay, is there anything important you want to do? Okay, now so after you have understood this, have you guys understood this? Is there any question? Then I will move on. If there is any question, I'm giving you an opportunity to ask me. What? Yeah, you can raise your hands and I will unmute you. Done? Should I move on? Okay, let me move on. Okay, so if you have understood that, then now let's use that concept and see how that concept is used to decide which one is a limiting reagent and which one is in excess. Okay, limiting reactant, limiting agent, or limiting reagent, whatever, limiting and in excess. Now, as the terms are self-explanatory, excess means something which is more than what is required. Excess means something which is more than what is required. Limiting means less than what is required. They're opposites. Okay, this is less limiting, meaning they are bringing the reaction down because the amount is less than what is required. So they are limiting the reaction. That's why it's called limiting reactant. Excess is what is more than required. Now the question is, in this reaction, if these are the masses, which one is a limiting reactant and which one is in excess? Let's find out. Okay. So we know that under ideal conditions, looking at this chemically balanced equation, the ratio is 1:1:1, and So if we translate that into molar mass, this is what we get. Okay, this is the mass ratio we get. So have you seen, did you see what they have done here? What have they done here? They have divided all the three masses by 10. So because they divided all the three numbers by 10, the ratio is the same. Ratio is the same as this. So 5.6 grams will react with 3.2 grams of sulfur to give you 8.8 grams of iron sulfide. But if in a question or in any situation, you are given 5 grams instead of 3.2 grams. Okay, so this was the ratio, right? This was the ideal ratio according to balanced chemical equation. This is the ratio that was there. But if in a question or in a situation, you are given, so iron is the same, okay, but sulfur is 5 grams. Sulfur is 5 grams. And the product which is being formed is again the same, though there is, so tell me, is sulfur less than required or more than required? This is the required. This is the required. And these are the other reactants. So now keeping this ratio in mind, looking at these two figures, tell me, is this in excess or is this limiting? Is this more than required? So in order to decide if it is in excess or limiting, compare it with the ideal value. Ideal value, and that you will get from looking at the mass ratio. And mass ratio, by the way, will be calculated from the molar ratio. That's why we're using the mass ratio, okay? Don't think that, you know, we can look at the mass ratio directly itself. No. After the mass ratio, we calculated the, after the molar ratio, we calculated the mass ratio, and then we are using the mass ratio. Okay, so now tell me, is this more than required or is this less than required? Who's gonna tell me? Come on, raise your hands and I will unmute you. Yes, Zainab? Yes?
Yes, it's more than required.
Right, because required was 3.2 and this is greater than that. So then, yeah. So then 5.6 gram reacts with 3.2 grams. So what it will do is, it will react with 3.2 only. It will react with 3.2 only. Whatever is left behind is left behind. You will see it as an excess left behind at the bottom of the container. You will see it not reacting and you will see it deposited at the end of the container. It won't participate in any reaction. Because why? Because these reactants react in a particular ratio. So whatever the number of moles was this, what was it? Did we calculate the number of moles? No. Yeah, okay. So whatever the number of moles was this, reacted with these many number of moles, and that's it. The reaction was over. Okay, because, so how much is left behind? 5 minus 3.2 is 1.8 grams was left behind. So we will say that 1.8 grams of sulfur was in excess. 1.8 grams of sulfur was in excess. Okay. So 1.8 grams will be left behind. Okay. Now, so according to this calculation, now we know that this was in excess. So this is in excess and this was limiting. Okay, remember, when you have one excess, the other becomes limiting. You know what limiting means? Let me tell you. Limiting is what drives the rate of reaction. Anything which is less is what decides the rate of a reaction. Okay, I'll give you an example. For example, in the market, if something, if for example in the market, something is short, okay, and another thing is in excess. Okay, let's say sugar is short and salt is in excess in the market. Okay, this is in excess and this is short. Shortage meaning it's not available in the market, or you can say that there are more consumers than the sugar available in the market. Then nobody would care about salt, right? Because it's excess. Nobody's worrying about salt. You know, you can buy it anytime. If not today, tomorrow. If not tomorrow, day after tomorrow. But sugar is short. So as soon as you see one bottle of sugar, you'll grab it. Because I never know if I'll find it tomorrow. I'm not sure if this bottle is available tomorrow. So I'll try to grab it, right? So in the same way, the reactant which is short is what determines the final rate of reaction, because that is important, because we are running out of it. The one which is in excess, the excess will be left behind. Okay, I hope my example helps you. I will come up with more examples, but I hope you get the idea. Okay, so even if the mass of reactants is in tons, okay, as in factories and industries, the reaction is in the same molar ratio. For example, now looking at the same reaction, but I have changed the units. So first we had 56 grams, right? Now I'm using 56 tons. But again, the ratio is the same, 32 tons, 88 tons, okay? So only the ratio is the same, the units have changed only. Now, if I add 3 zeros, make it 1,000, same thing, ratio is the same, okay? I hope you got that point, okay. Now, yes. Now, I hope you have understood this. Have you understood this? Is there any question regarding limiting reagent and excess reagent? If there's any question, please raise your hand. Okay, okay. You can ask me questions. I mean, you can raise your hand even while I'm explaining, in the middle of my explanation, and I will let you know. And then I'll give you a chance after I'm done. Okay, Nabil. Yes, Nabil?
Won't we make the excess amount less?
Sorry?
Limited. Won't we make the excess amount less?
Won't we make the...
Increasing?
Well, I cannot hear you clearly. Can you please speak a little more clearly? Are you trying to say that can we decrease the excess? What?
Yes. Yes.
See, yeah. See, I'm just giving you. Can you mute yourself? Okay. So I was just giving you, you know, an example. I was just giving you a situation. You know, if you come across situations like that when you have excess, how do you calculate excess? Of course, you can decrease and increase. But you know, ideally in real life situations, this is how you know, you don't get exact ratios, right? You have your own amounts, and so you have to decide using these calculations which one is in excess and which one is limiting. Sometimes you have less than required, sometimes you have more than required, right? So how do you calculate? As we do questions, things will get clearer. Okay, how do we apply all these concepts in questions? So this is a worked example. So after you have understood that, now this is a worked example, and this is given in your book. So I got this from your book. Okay, let's read the question. What mass of aluminum oxide is produced when 9.2 grams of aluminum metal reacts completely with oxygen gas? Okay, what mass of aluminum oxide is produced when 9.2 grams of aluminum metal reacts completely with oxygen gas? Now, my first step of solving any stoichiometry question is to write a balanced chemical equation. Balanced, okay? I emphasize on the word balanced, because if it's not balanced, you won't get the information you're trying to get, okay? So I know the reactants, and also you should know the formulae, how to write, you know, because if the formulae are not correct, then the equation won't be balanced. Now, aluminum, so aluminum symbol is Al, is aluminum oxide is produced. So that's my product, okay? When 9.2 grams of aluminum metal reacts completely with oxygen gas. So oxygen is here I know oxygen is a diatomic molecule and it's in the gaseous state. This is a metal, so this is solid, and this is also solid. Okay, now I know the formula for aluminum oxide. I hope everybody who's attending this class knows how to write the correct formula for aluminum oxide. Oxidation state of aluminum is +3, of oxygen is -2, so we crisscross and that's how we get it. And so I went ahead and I balanced the equation. And so according to my balanced chemical equation, the ratio is 4:3:2, right? The ratio of aluminum reacting with oxygen to give aluminum oxide is this, 4:3:2. Now, after I have done this, my next step would be what data is provided by the question. I will write that data down and see what are they asking me to find out. What mass of aluminum oxide? That means I have to calculate the mass of aluminum oxide that I don't know. They have given me the mass of aluminum. They have given me the mass of aluminum reacts completely. You know what the word completely means here? Meaning, according to this ratio, complete means complete reaction, according to this ideal ratio. Meaning you don't have to consider the loss to the surroundings. You don't have to consider anything else. You just follow this ratio, simple, straightforward. But they did not give us the mass of oxygen. They did not give us the mass of oxygen. But that's okay. We have the molar ratio and we have the mass of aluminum. I think that's pretty much enough information for us to calculate the mass of aluminum oxide. So again, what do I want? I want to find out how many moles is this. Why? Because I want to know, I know that 4:3:2. So if I know the number of moles of aluminum, then I know the ratio between aluminum and aluminum oxide is 4:2. Using this ratio and the number of moles of aluminum, I can calculate the number of moles of aluminum oxide. And if I know the number of moles of aluminum oxide and I know the molar mass of aluminum oxide from this, using this periodic table, I can find out the mass. Okay. Third step. So I will find out how many number of moles is aluminum. How much is it? Number of moles, how do we calculate? Mass divided by the molar mass. What is the mass? This mass divided by the molar mass, this mass is the mass that you are using in the reaction. According to the question, this is the mass of aluminum which is being used in the reaction. So that will be my mass, 9.2 grams. Okay, and remember in standard calculations, the unit of mass should be grams if you're dividing it by the molar mass. If you're given in kilograms or tons, I think you'll have to convert it into grams, okay? To divide it by the molar mass to get the number of moles. What does molar mass means? The mass of 1 mole of aluminum. And that I got from the periodic table. That's 27. Okay, that's 27. I hope you can see it in the camera. So I will divide 9.2 grams divided by 27 and I got 0.34 moles of aluminum. Okay, 0.34 moles of aluminum when I divided 9.2 grams by 27. So now what is the ratio? 4:2. So 4:2 aluminum and aluminum oxide. So number of moles of aluminum in the question is 0.34. So how many aluminum oxide? How many number of moles of aluminum oxide? So I will multiply 2 by 0.34. Remember? I hope you guys know this ratio method. Okay, I hope you guys know what I'm doing here. So whatever quantity you're trying to calculate or find out should be written on the right side, and the information that is given that is helping you should be written on the left hand side. Okay, so so whatever a pair of information you're given should be written at the top, and the one that you're trying to find out should be written at the bottom, and then you cross multiply the figures which are written across each other, and then you divide by what you're left behind with. Sorry. Okay. I hope you get this ratio method. Okay. So, okay, now let me do this. So what is 0.34 multiplied by 2? If you have your calculators, 0.34 multiplied by 2 is 0.68 divided by 4 is 0.17 moles of aluminium oxide. So this is 0.17 moles of aluminium oxide. Now it's easy to calculate the mass, right? If you know the number of moles, you can find out the mass. How can we find out the mass if we know the moles? Okay. Who will tell me? Who will tell me what should be my next step? How can I find out the mass of aluminium oxide after I know the number of moles? Who will do the last step? I want somebody. Ajwa. So this is the number of moles of aluminium oxide. What is the mass? Laiba, Marwa. Are you guys with me? Okay, good job, Ajwa. Yes. Yes.
Mass equals moles multiplied by MR.
Sorry. Okay, your voice was echoing. Can you say it again?
We can find the mass by multiplying the moles with the MR.
Yes, and MR is? MR means what? Molar mass, right? Okay. Yes. So 0.17 multiplied by the molar mass. How do you calculate the molar mass of aluminium oxide? We did this in the last class, but let me recap. One mole of aluminium has a mass of 27 grams multiplied by 2 because we have 2 of aluminium. And then we have 3 of oxygen. 1 oxygen atom's mass is 16. I'm multiplying it by 3 because there are 3 oxygen atoms here. And so when I multiply 27 by 2, I get 54. And when I multiply 16 by 3, I get 48. And when I add them, I get 102 grams. So that is the molar mass of aluminium oxide. Okay, so if 1 mole has a mass of 102 grams, then 0.17 moles will have how many grams? I'll multiply 102 by 0.17 and then I'll divide by 1, and so my answer is 17.34 grams of aluminium oxide is produced. Now, in this whole calculation, if there is any point that you did not understand, please let me know right now, but I want you to tell me exactly which step you did not understand or exactly what point you did not understand. So I'm ready, I'm waiting. If there is anybody who did not understand any step, it's okay. But you have to tell me which step you did not understand. What concept, what word, what term you did not understand. Then please let me know. Ahmad 31. Yes, is there anybody who wants to ask a question? Yes. Okay, so that means everybody is clear. Okay, fine. Okay, Nabil. Yeah, I appreciate questions, but your questions should be clear and to the point. Yes?
I understood the last one, how we got the moles.
Sorry, can you please speak a bit clearly? I cannot understand you. Yes?
The last point, how we got the moles.
From which part? From where? Till where did you understand? Tell me.
Till the mole part. How did we took the mass from
No,
the
did you
moles?
understand how I calculated the moles of
Yeah.
aluminium oxide? Did you understand
Yeah,
this?
I understood this.
Okay, this is more difficult to understand. Okay, if you understood that, this is easy. So I know from the periodic table, I mean, when I calculated the formula mass, go ahead and mute yourself, Nabil. So mass of 1 mole of aluminium oxide is, did you understand this? Okay, I need to unmute you. You have a lot of background noise, Nabil.
Yeah.
Okay, did you understand this, Nabil? Okay, so if you understood this, then you know this is nothing. 1 mole has a mass of 102 grams from here. 1 mole has a mass of 102 grams, and so how much will 0.17 moles have? 0.17 moles is what was being produced from this reaction in the question. So if 1 mole has a mass of 102 grams, what will be the mass of 0.17 moles? So multiply the ratio method, 102 multiplied by 0.17, and so you get 17.34. I hope you understood. If you understood, just lower your hand. I will assume that you have understood. If not, then you can ask me again. Okay, Marwa, did you understand? Yeah, because you know, now we have less participants, I can actually pay more attention. Marwa, I'm trying to unmute you. Yes, Marwa, did you understand? Okay, listen, you have to respond to me and you have to participate in my classes. I have to know that you are interested. Okay, otherwise there are a lot of students who want to get in. So I would, you know, give them a chance, the ones who are more serious. Marwa, it's okay if you make mistake. Don't be scared of me. It's okay. Because you see, then what's the point? If I'm just speaking, and you know, I don't know if you have understood or not. Okay. Okay, so this is done. Okay, and then I want to do this question at the end of the chapter, which was done by Nabil. This question number 2 at the end of the chapter, 171. Okay, question number 2, part D. And I copied it down here. Okay, this is the end of chapter question from your book, but I copied it down so that you know it's visible. The equation below shows how the fertilizer ammonium sulfate is manufactured. This is ammonium sulfate. It is manufactured when sulfuric acid reacts with ammonia gas. Okay. Now in this reaction, 17 grams of ammonia produce 33 grams of ammonium sulfate. What mass would 3.4 grams of ammonia produce? Again, my first step is a chemically balanced equation, which they have already given in the question. So I'm just copying it down for my convenience. Okay, so they have given me ammonia and they have given me ammonium sulfate. So these are the two substances, the ratio of which I am concerned with, right? So according to the coefficients in the balanced chemical equation, and when you don't have any coefficient, that means there is 1. So the ratio is ideal ratio according to the equation. The ideal ratio is 2:1. 2:1. For every 2 moles of ammonia will give you 1 mole of ammonium sulfate. That's what it means. Every 2 moles of ammonia will give you 1 mole of ammonium sulfate. But in the question, what they're trying to show is that this ratio is practically not the case. Practically speaking, this ratio is not followed. What are they saying? That in this reaction, 17 grams of ammonia produces 33 grams of ammonium sulfate. Now I have to double check. Is this, now this is mass, right? Is this the same as the ideal ratio? Is this the same as the ideal ratio? So how will I find out? I have to convert this into the number of moles. I have to convert this into the number of moles. Is this the same as the mole ratio? I'm trying to check. So I'm divided. How do you calculate the number of moles? Simple, mass divided by the molar mass, right? Number of moles is equal to mass divided by the molar mass. Mass is 17 grams according to the question. 17 grams, I got that from the question, 17 grams. Molar mass from the periodic table, okay? Ammonia is NH3, right? Hydrogen atomic molar mass is 1, and there are 3 of it, 3 hydrogen atoms, so 1 multiplied by 3 is 3. Nitrogen is 14, okay, according to the periodic table. Okay, I got these figures from the periodic table. So 14 plus 3 is 17, right? So the molar mass is 17. So 17 divided by 17 is 1. So that's the number of moles of ammonia. And what about ammonium sulfate? Again, mass divided by the molar mass. And if I add up the molar masses of each element here, I hope you know how to do that. I got 132 grams, yeah. Okay, and that would give me 0.25 moles. So the actual ratio, the actual practical ratio is this. This was the ideal ratio according to the equation, and this is the actual practical ratio. So is it the same as the ideal? What does this mean? This means ammonium sulfate is half of ammonia. Isn't this telling me that the number of moles of ammonium sulfate is half the number of moles of ammonia? But is this the case here? Is this half of 1? No. Half of 1 is 0.5. Yeah. So this should have been 0.5. This should have been 0.5, but it's not. But it's not. It is the half of 0.5. It is the half of half, 0.25. Right, quarter. It is quarter of 1. Okay. So now we will not use this ideal equation for our calculation. We will use this actual equation, because that's why they gave this piece of information, that keeping this ratio, now tell us what mass would 3.4 grams of ammonia will produce. So now it's easy. Now we will use this ratio, okay? Keep this ratio in mind. Now, this is the equation. I have written down the actual ratio. I did not write down the ideal ratio, which I get according to the balanced equation, but this is the ratio I will use. 1 is to 0.25. Now, using this ratio, how much 3.5 grams of ammonia will, how much ammonium sulfate will be given by 3.4 grams of ammonia? So again, this is ratio method. I'm sorry. First, I have to convert this into the number of moles. Yeah, because I cannot use the mass directly, okay? Many people do that mistake, but don't do that, okay? You cannot directly just, with the help of mass use ratio method and find out. You have to convert this into the number of moles. Again, number of moles is mass divided by the molar mass, and this is the mass of ammonia, remember? This is ammonia. We know that the molar mass of ammonia is 17, right? And the mass is 3.4 grams according to the question. The question is asking what mass would 3.4 grams of ammonia produce. So 3.4 grams divided by 17 got me 0.2 moles of ammonia. Now I can use this piece of information in the ratio method, okay? So again, I'm using the ratio of 1 is to 0.25 because that was the ratio, okay? So 1 mole of ammonia is giving me 0.25 moles of ammonium sulfate, then 0.2, which I got from here, moles of ammonia will give me, cross multiply, 0.25 by 2, divide by what you're left behind with, 1. So I did not write 1. So I got 0.05 moles of ammonium sulfate. Now the question is asking me the mass. Easy. Number of moles is mass divided by the molar mass, right? So I want to find out mass, okay? So mass would give me number of moles. Are you guys with me? Are you understanding, or are you finding this very difficult? It does look difficult, but once you get the hang of it, it's really interesting. So number of moles multiplied by the molar mass. So number of moles is 0.05. From here, molar mass is 132. I calculated from the periodic table and I got 6.6 grams. Did you understand this? Nabil, you had done this question with for us, remember, in the last class? But then I said I have to explain this myself because I had not done all of this. I had not explained all of this by that time. Okay, is there any question in this? Please don't be shy and ask me. Yes, Zainab? You know, when there was chat box, you used to ask a lot of questions. And now when I'm asking you to ask questions directly, I cannot see a lot of hands. See, that's the thing. You're behind the keyboard, students feel very brave. Okay. Yes, Zainab?
I'm really sorry, miss, but over here,
No, you don't have to be sorry. It's okay. This is your right to ask questions. Yes.
over here, when you multiplied the 0.25 from the ratio, what does this 2 over there stand for?
Can you ask that question again? What does what stand for?
Like when you were using the actual ratio, 1 ratio 0.25,
Yes.
1 mole of NH3 gives us 0.2 moles of NH4,
Yeah, and
ammonium sulfate.
Yes, okay.
So over here, then 2 moles of NH3 will give us.
No. This is not 2. This is 0.2. 0.2.
Yeah, 0.2 moles of NH3 will give us the 0.2 times 2. What does the 2 stand for?
Oh, sorry. Oh, yeah. Thank you very much. Yes, sorry. This is this is a mistake. Yeah, so 0.25 multiplied by 0.2. Sorry, not 2, 0.2. That's a good question, Zainab. Yeah, so this was a mistake in my, so 0.05 multiplied by 0.02. Okay. What did I do here? Okay, this must be some mistake. 3.4 divided by 17 is 0.2. So this should be, okay, so 0.25 into 0.2. Yeah, okay. This is 0.2. Okay, Zainab? Are you clear? Okay, is there any other question regarding this equation, this question? Is there any question? Is there any step you did not understand? Like Zainab did not understand this step. Is there any other step in this whole working? Because I want you to be clear about this, because these are the sorts of questions you will come across. You should understand each and every step. So first step is writing balanced chemical equation. Then looking at the balanced equation, you should know the ideal ratio. Okay, see if the question has talked about any actual ratio, any practical ratio. If they have not given, we will assume this molar ratio to be true, this ideal ratio, and we will use the ideal ratio. If not, if the question has provided you with any, practical masses, in a reaction, then you will have to find that out. What is that ratio telling us? Okay, is it the same as the ideal ratio? If not, then there are, this gives us two pieces of information. One is that, what is this telling us? That some is being lost. This should have given us 0.5. This should have given us 0.5 moles of ammonium sulfate, but I think some is being lost to the surroundings. or, you know, somewhere else. So actually, you know, practically speaking, that's not the case. For each mole of ammonia, we are getting 0.25 moles of ammonium sulfate. Okay, and so this looks like, okay, can ammonium sulfate be a limiting agent? Can ammonium sulfate be a limiting agent in this? It's a product. Product cannot be limiting or excess. Okay. Limiting and excess agents are the reactants, not the product. Okay, that's another point I forgot to mention while talking about excess and limiting agent. We are talking about the reactants. The product can never be limiting or excess because that's what is being produced by the reaction. It cannot affect. So limiting and excess are always the reactants. Okay, I hope this is clear. If not, please go ahead and raise your hands. Okay, Marwa, that's fine. Okay, then okay, what was the other? Yes, this is the other question. Does this also have limiting and excess, right? Okay, so we'll discuss this. Okay, this is question number 4. This is question number 4, part B. Okay, again, end of chapter question. A compound contains only aluminum and carbon. This is your book. These are your book questions, okay, at the end of this chapter. So I'm doing them as I'm covering the topic, okay? So we have done limiting and excess reagents, so let's do this. A compound contains only aluminum and carbon. 0.03 moles of this compound reacted with excess water to form 0.12 moles of aluminum hydroxide and 0.09 moles of methane. This is methane, okay? That's the name for this gas, CH4. Write a balanced equation for this reaction. So you have to write this equation yourself. How will I write it? Let me write it for you. I mean, let me show you how I wrote it, okay? Let me show you how I wrote it. Can I have a rough piece of paper from there? Jazakallah khairan. Okay. Okay. So what is the information given to us in the question? A compound contains aluminum and carbon, okay? Now I know in the periodic table, aluminum is more on the left side than carbon. So +3, and this is plus or -4. So we know group 4 elements usually share electrons. They form covalent compounds. And then on the more you get on the left-hand side of the periodic table, the more metallic the elements are. Metallic meaning more readily they give off electrons, right? So of course, aluminum has a greater tendency to lose electron compared to carbon. Okay, so this must be positive by losing electron, and this must be relatively, you know, negative. Not negative, but compared to aluminum, yes, it might be negative. So whenever we write a formula of a compound, we write the positive first and then the negative. So I know aluminum and carbon. Now because aluminum is in the third group, the charge its ions are going to have is +3. This is from your grade 6, 7, 8. You know, you must be knowing this already. So the oxidation state of aluminum is 3, and carbon can be +4 or -4, depending upon, you know, if the other compound is more positive. If it's more positive, then it would be negative, and if it is negative, it would become positive. Okay, because someone has to lose, the other has to gain. So it's like that. So this is +3. Let's say this is -4. Okay, so this will go here. This will come here. I know you know this. Al4C3. Okay, using this information, I write this formula here. Now they are saying that this compound, 0.03 moles of this compound reacted with excess of water. So water is excess. Okay, whenever they mention in the question that this is excess, then you know that you cannot use its number of moles to calculate the ratio, because the number of moles or the mass is more than what is required. So you cannot use its number of moles to calculate the ratio. Okay, I hope you get that point. Okay, because this is an excess, this is more than what is required. So it reacted with water to give us, to form 0.12 moles of aluminium hydroxide. Aluminium hydroxide. Okay, now, and also methane, CH4. Okay, now how do I balance it? Now I know I have 4 of aluminium here. So let me add 4 here. There are 3 carbon here. So let me add 3 here. Okay, I hope you're understanding. And then how many hydrogen are there? 4 3s are 12, 3 4s are 12. So 12 from here and 12 from here gives me 24. So what should now I already have 2 here. So what should I multiply it with to get 24? 2 12s are 24, right? So 12, let me write 12 here. 2 12s are 24. Now, what about oxygen atom? 4 3s are 12. And so, yeah, 12. So this is balanced. So my final equation would go something like this. Let me write it neatly. So aluminium carbide is reacting with water to form aluminium hydroxide. And okay, so this is the balanced equation. So what is the ratio? 1 is to 12 is to 4 is to 3. 1 is to 12 is to 4 is to 3. Okay. Now, what are they? So we did this part. Now the second part is 0.07 moles of silicon reacts with 25 grams of bromine. Now this is a totally different question. So moles of silicon reacts with 25 grams of bromine. So this equation was given in the question. So we already know this from the question. This was already given. We know bromine exists as a diatomic molecule. Okay, there are 4 here, and so 2 2s are 4. Which one is the limiting reagent? That's the question. Okay, I hope you guys are not sleeping. I hope I did not put you to sleep. Okay, which one is the limiting reagent? Now, how do I find out the limiting reagent? Can anybody tell me what approach should I use? How do I? Now, this is the piece of information they have given me. They have told me 0.07 moles of silicon. They have told me 0.07 moles of silicon and 25 grams of bromine. So they have given me the number of moles of silicon, but they have given me mass of bromine. And they are asking me which one is the limiting reagent. So what approach should I use? Any idea? It's okay to be wrong. It's okay. You know, based upon what we have already done, whatever comes to your mind. But I want you to think. Yes, Arij, I appreciate. Yes. Okay. Yes, Arij.
Ma'am, mass divided by molar mass.
Of what?
Of bromine.
Very good. Very good. That's correct. So so why and how? I mean, why did you go for the number of moles of bromine? It's okay. It's okay. Yeah, you know it, but put it into words. Yeah. Because you know, that's the first step. After balanced chemical equation, you have to know the number of moles. So how many moles will react with 0.07 moles of silicon? So you want to find that out, right? Arij? See, that's the thing, you know, in the chat box, you guys are very active. Now, when I unmute you, you don't want to talk. Which one is the limiting reagent? So yeah, RH is correct. So we know the number of moles of silicon. So basically we have to translate everything into number of moles. That's very important because it is actually the particles that are reacting. Okay, they might have different masses, but it's the number of particles. Okay, that will determine the final mass. Okay, so we will calculate the number of mass of bromine by dividing the mass that they have given us in the question divided by the molecular mass. Okay, so 25 grams divided by the molecular or the molar mass of bromine. And from where did I get this? Periodic table. Okay, bromine, one atom is 80. Can you see? Is it clear in the camera? So bromine is 80. Can you see? Okay, so bromine is diatomic molecule. So I multiplied 80 by 2, which is 160. So the molecular mass for bromine molecule is 160. And so 25 divided by 160 gave me 0.156. Now, according to the equation, the ideal ratio is 1:2. The ideal ratio is, according to the equation, 1:2. Okay, there is no coefficient here, so that means this is 1. So this should have been double. This should have been double according to this. But is this double? What is the double of 0.07? Double of 0.07 is 0.14. Double of 0.07 is 0.14. This should have been 0.14, but this is 0.156. So is this greater than what is required, or is it less than what is required? Who's gonna tell me? Is this a limiting reagent or in excess? Yes, I wanna see hands. Very good, Sal. Yes?
It's in excess.
Very good, because 0.156 is greater than 0.14, so this is an excess. So that means this is an excess, so then that means this must be the limiting reagent, right? If one is excess, the other one will be the limiting reagent. So the limiting reagent in this question is silicon, and bromine is in excess. By the way, the answer to this question in the DVD of the book, I don't know if they got confused or what. I don't know. They have given the same working, same everything, and you know, they have called bromine in excess, but then they are calling the same bromine as a limiting reagent as well. And I don't understand why they have done. Maybe it's a printing mistake or something. But anyway, how can the same substance be in excess as well as limiting reagent at the same time? That's not possible. Okay. So yeah, that's how we conclude that silicon is our limiting reagent. Okay, so 1:2, and then 0.07 should have given us 0.14, but we got 0.156. Therefore, bromine is in excess. And so bromine cannot be the limiting reagent. So silicon is the limiting reagent. Okay. Okay, then the next part of this question is how many moles of silicon bromide are formed? Okay, again, I will use this balanced chemical equation, the molar ratio that I got from this equation, molar ratio. Now I have the moles of silicon from, you know, part B. I know that the moles were 0.07 from part B. And so now they're asking me how many moles of silicon bromide are formed, and the ratio is 1:1. So I'm only concerned with these two, 1:1. Because this is an excess, I will not use this to determine, because this is an excess. Remember, I told you whatever is in excess, you do not use it to determine the mass of the product. You do not use it in order to determine the molar ratio or mass ratio or whatever, if it is in excess. So I will use silicon because that was the limiting reagent. So 1:1. That means the number of moles should be equal, 0.07, 0.07. So if I know, yeah, so that's the answer, 0.07 moles of silicon bromide. But if they had asked you the mass, then you could have multiplied that number of moles by the molecular mass of silicon bromide. So I went ahead and I did this. I thought they were asking the mass, but they were asking moles. So your answer ends here. Moles of silicon bromide. Okay. So these were the end of chapter questions, and I think we have run out of time. So in the next class, we will do the calculation of the percentage of purity and percentage yield, because you know these questions took all the time. Okay, is there any question? Please go ahead and raise your hands and ask me. In this calculation, if there is any question, you are free to ask me. Is there any step you did not understand? Is there any concept you did not understand? So the take-home message is that you should know what a limiting reagent is. You should know what an excess reagent is. That's the take-home message from today's class. Is there any questions? Zainab, Ajwa, Fatima, Laiba? Okay. Okay. So I am assuming that everybody has understood. Okay, best of luck. Go ahead, and I will post the previous classes in the group. Watch them, revise your work. Okay. And again, tomorrow, again, chemistry class, same time. And we will continue with the calculation of the percentage purity and percentage yield. Okay. Okay, same ID, same password. So I will not email you or post in the group anymore. I will not post in the group meeting ID, passwords, and the timings. Okay, I will email individually. Okay, so same time for tomorrow, same meeting ID, same password. Okay, chemistry, percentage purity, percentage yield. Okay, inshallah ta'ala. Assalamu alaikum wa rahmatullahi wa barakatuh.